So what exactly prompt engineering? Prompt engineering is an emerging skill set focused on designing and optimizing inputs for AI systems to ensure they generate optimal outputs. There are emerged multiple patterns. First one I would like to discuss is one-shot, few-shot, and zero-shot prompts. Zero-shot prompts is when we just ask model to do something and rely on model itself to provide our answer in a certain format. But one shot or few shot is where we provide examples of how output would like to be, how we would like to see the output from the model. Hello. My name is Andrei. I'm a mobile developer and team lead. I live in Oslo. Originally, I'm from Russia. Currently, I'm working in a health tech company called Dignio. We're developing apps for patients and healthcare employers. It's very inspiring because our applications help patients to improve their health and, in some cases, save lives. But also, I'm a generative AI enthusiast, as maybe a lot of us these days. And yeah, in this talk, I would like to share what I learned from using generative AI as an iOS developer. So I would like to start from discussing how LLMs work on a high level, because this understanding can be very useful for some prompt engineering techniques. Then I'll talk about using generative AI as a service, how we can use it as a backend or as addition to our backend to implement new features or enhance user experience in our mobile apps. And then I'll talk about prompt engineering patterns. There are many patterns emerged to how structure prompts for safety and efficiency. And in the last part, I briefly talk about generative AI as a tool for pair programming. Yeah, this famous abbreviation, GPT, what it actually stands for. Generative means that these models generate new text. Pre-trained, trained means that these models are trained on a huge amount of data, basically all textual information from the internet and some information from custom data sources. And pre-trained means that we can fine-tune these models for custom tasks with additional training or using prompt engineering. And transformers refers to architecture, that like transformer architecture, that's basically core innovation behind revolution of generative AI revolution that happened a couple of years ago. So GPT architecture is a slightly modified transformer architecture from original paper, Attention is all you need. It has only decoder component from this architecture. So it starts from input processing, input processed in a special format, understandable for decoder. Decoder generate text, and on top of that, for the most advanced models, we have an additional layer which is responsible for context handling, session handling, safety, and content filters. Also, this layer contains bootstrap prompts. This layer similar to business logic layer in our apps, in mobile apps. So how actually input is processed? Every sentence or all the input is split into tokens. And token usually represent one word, but sometimes this is just a part of the word, and punctuation. Then every token is converted to embedding. And embedding is a vector. And for ChatGPT, this vector has more than 12,000 dimensions. So basically this vector, every number in this vector represents one feature of semantic meaning of this word. And these vectors are placed into 12,000 dimension space. And in this space, words with similar meaning are collocated. Because, for example, in this sentence, Swift can have multiple meanings depending on the context. It can be programming language, but it also can be verb fast. And Apple can be fruit or can be a huge company developing mobile applications. What this allows us to do is basically to understand how each word is relevant to each other word in the input. And also, it allows us to perform mathematical operations on semantical meaning of the words. For example, if you take word Google and substitute from it word Kotlin and add embedding of the word Swift, so basically this vector will encapsulate semantical meaning of Google without the semantic meaning of our Kotlin, and also include semantic meaning of our Swift. Any guesses where we arrive in this multidimensional space? It's Apple. So when we substituted Kotlin from Google, we arrived to a meaning of a large company developing mobile apps, but without programming language. And when we added Swift, we arrived somewhere where Apple is located as a meaning of a huge company with a programming language. But actually, it's not only Apple there. Nearby companies with a similar kind of vibe: Spotify, Amazon, Netflix, all like huge companies that probably develop mobile applications for a huge amount of users using probably Swift. So looking how it works all together, when we process a stream of input is converted to a stream of embeddings. And each embedding goes, and this stream goes through multiple layers of transformers. And each embedding also contains positional information about where word is located in the sentence. Because the main innovation in transformer architecture is that transformers can attend to these vectors in parallel. So they require positional information. And so when all the embeddings go through all the layers, it's 120 layers for GPT-4. What we get at the input, at the output, like intermediate output, it's a prediction for one word that completes this input. So what transformers produce is a list of words with probabilities. And according to algorithm and configuration for this model just selects one word to complete the input. And what happens next, it's kind of straightforward. We append a new prediction to the input and send it to go through this process all over again. Intuitively, it seems it would never work. It seems it would generate some kind of nonsensical data. And for small models, it generates not so reasonable answers, but when model achieves certain size, some magic happens. For example, GPT-4 has 1.7 billion parameters, and when we have so many parameters tuned with huge amount of data, it starts to produce amazing answers. And what actually going on inside these layers, nobody knows, because it's 1.7 billion parameters, and what happens, it's like just a mystery. And predictable AI, it's a big area of research, because as it is now, it's not possible to use this architecture for mission-critical tasks, because it's not deterministic, and also we all know these models can hallucinate, can provide answers that look very like a model very confident in it, but it's actually something they just come up from the thin air. So how can we use generative AI in our apps? First option is use OpenAI API. We can just post a very simple JSON to OpenAI API URL. And this JSON contains a model. We need to select model. GPT 3.5 Turbo is a very capable model. It's not as capable as GPT-4, but with generative AI, it's very important to understand your use case. You not always need the most capable model, because most capable model will consume more resources, it will be more expensive, and for some use cases, smaller models will work just fine. We have array of messages with role and content is basically our prompt. And we have array of this because by default, OpenAI API doesn't keep track of conversation. So if we want to implement something like a chat, we need to send all previous messages with answers back to the model in order to keep it track the context. And temperature is basically algorithm by which model selects which next word to select as a prediction. If we set it to 0, it will try to be the deterministic as possible. It will always select most probable word. But if we set it to 1, it will select sometimes not as probable words. So it will so output will be more creative. So depends on our use case. We can tweak this parameter to achieve results we want. If we want to compile something that we want to be repeatable and deterministic, we always should set temperature to 0. But for more creative output, we would like to experiment with higher temperature. In our mobile app, we can create simple struct to represent our payload. We can create our AI request and even static builder method to initialize all parameters of this message. And in this case, we need to hard code all the parameters in mobile apps. In mobile app, we need to hard code model and temperature. It's not so flexible. Of course, we can have some kind of backend endpoint where we can fetch this configuration, but still it requires additional development. And somewhere in the service layer of our app, we can have invoke method, asynchronous invoke method, that just receives prompt and outputs answer from our model. We can initialize URL request with OpenAI URL and configure tokens for this API, encode our request, and basically standard way of decode our response. This API returns multiple choices. In some cases, we can present multiple choices of answers to users, but in most cases, we can just show the first one, and it will be enough. And now, if I ask describe Turin in one sentence, it will answer Turin is a historic city in northern Italy, known for its Baroque architecture, rich cultural heritage, and delicious food. And from being here a couple of days, I can confirm it's not hallucination. It's the most straightforward way to use API, but to use generative AI, but it's the most expensive one. So as we can see, a price for 1 million token can be up to $60. And when we send a prompt, we pay for input and output. So we pay for question and we pay for answers. If we want to, if our app becomes really popular suddenly, that's all. We all want that, but unit economics of the app should accustom for price that can incur if a lot of users use our app and call OpenAI API. Some apps allow users to enter their own token, but it's not optimal user experience. Another option to use a service provider like AWS. It's also possible to do the same with Google Cloud or Azure, but on Amazon, the service called Bedrock. Bedrock service gives us a possibility to choose from multiple foundation models. And foundation models, they pre-trained on a huge amount of data, slightly different. These models come from different providers, from Amazon itself, from Anthropic, from Facebook, except OpenAI, because OpenAI models are not open. Main advantage, it requires additional configuration, but price is significantly lower. So it can be from 30 cents for 1 million token. They have Titan, it's Amazon's model. Claude 3 is very very capable. It's on the same level of capabilities as the GPT 3.5 Turbo. And they recently released Claude 3 Opus, which is as powerful as the GPT-4 and maybe even more powerful in some cases. They even have an API for image generation. So this configuration can look like this. Our iOS app can call AWS Cloud Services. It can start from API gateway to send HTTP request to API gateway that provides REST endpoint. This REST endpoint can call Lambda function that invokes Bedrock model. And Bedrock model returns output to our Lambda, and at the end, in the app, we receive output as a response to our HTTP request. The only downside to this approach, API gateway has a timeout of 30 seconds, and generative AI tasks can be very compute intensive, for example, image generation, and it can easily exceed 30 seconds for processing some inputs. If we need to implement compute-heavy tasks, we need to adjust this architecture and maybe store our output somewhere in S3 and send real-time notification to iOS app when our output is ready. This is some Python code. This Python code invokes our model. I think it's possible to write it in Swift, but it's really much easier to use Python because all examples are in Python, and AWS provides Python library for invoking models, and it's basically all the code we need to invoke the model. We have prompt in a special format. In this example, I selected Claude 2 model, and it has a predefined format of the body we need to provide. Again, we provide the prompt, maximum number of tokens, and temperature. Again, temperature determines how creative our output will be. Then we just invoke our model and send back completions. And the next function is what is getting invoked when we send request to when we send the HTTP request to AWS API. So we can provide content in our JSON body of post request, and we need to provide some kind of authentication mechanism. We can provide just hard-coded key or integrate with security services like Cognito. And we can just send a response after invoking model as a content JSON. So now we can post a very simple message to Amazon API and provide the same prompt. But now we are re-implemented what we already had with OpenAI API, but we can do better because now if we want to tweak our prompt, we need to tweak it in the app and redeploy the app to see how it affects our outputs. What can we do? We can create a function that template function that takes content our prompt and returns a templated prompt. In this example, I created a template that has a schedule and title and abstract of all the talks of this conference, and I provided prompt for assistant to find the most relevant answer in the context. And context is a schedule. And to signify schedule, I just created XML-like tags for a model to understand. And content is embedded in question tags. Okay, so now, when we invoke Lambda function, we can provide additional parameter template and based on this parameter, we can invoke different templating function. In this way, we can iterate more quickly. We can change template in our request and get completely different output, depending on our needs. So now, if we post this message, we can provide template parameter in our response and ask the same question. In the app, we can modify our data transfer objects and create template as an enumeration. And instead of invoke function, we can create invoke and just decode another message and return output as a string. So now, if we use it, and we can provide a schedule parameter as an enumeration template. So now, if you ask the same question, describe Turin in one sentence, answer will be Turin is a host for Swift Heroes Conference 2024. So now, model actually acts on your data and provides responses based only on schedule, because schedule is wrapped into context tags, and it's very important to limit model. If we just let users ask any questions, basically it would be very unsafe. We need to restrict what users can do with our models. But if I ask, can I learn something new about psychology? It won't answer anything about psychology and says, yes, you can learn something new about psychology from this conference, specifically from this talk, Art of Balanced Life, discussed the balanced work, and it goes to provide all the abstract. So it provided very good suggestion how to learn about psychology from this conference. So what exactly prompt engineering? Prompt engineering is an emerging skill set focused on designing and optimizing inputs for AI systems to ensure they generate optimal outputs. There are emerged multiple patterns. First one I would like to discuss is one-shot, few-shot, and zero-shot prompts. Zero-shot prompts is when we just ask model to do something and rely on model itself to provide our answer in a certain format. But one-shot or few-shot is where we provide examples of how output would like to be, how we would like to see the output from the model. So in this prompt, I asked a model to summarize all the talks between context tags. And again, I just pasted all the talks as a text, just took them from the site, Swift Hero site, and pasted them as a text, because Claude model has 200,000 words context window, so it can handle very large prompts. And if you want to provide output in a certain content type, we can just ask model to do that. In this case, I ask model to provide output as an array of JSON objects with title, one main topic, and an array of tags. And I ask model that tags should not repeat the main topic. And to make it one-shot prompt, I provided an example. I took inclusive design talk, I pasted abstract, and provided example. So I made the main topic accessibility and provided an array of tags. And contexts, I put it in the bottom. So sometimes it's important to understand how model works, because it keeps predicting new words. It just can't go back and change something in what it's already predicted. So sometimes it works better if you put contexts in the bottom. So when model goes through the context, it already knows what we would like to do with this context. And output looks like this. In building Swift CLIs that your users and contributors love, topic, Swift CLIs, and tags, terminal, twist, contributors. In Marco Polo new generation of code generation, it identified topic as Swift macros and tags as code generation, modules, examples. In type state, the new design in Swift 5.9 topic is a type state design pattern and tags state machines, memory ownership, generics, constraints, and safety. A tale of model architectures, MVVM, SwiftUI, and SPM. I think it's done pretty good job on this task. Another pattern is persona and audience. With this pattern, we can tap into different layers of knowledge. We can use these patterns on their own, but it's very powerful when we use it in combination. So we can, for example, ask, how does async await works in Swift? And we can ask it to act as someone. In this example, I ask model to act as experienced iOS developer. This is a persona pattern. And audience pattern is explain to, and explain to where use out. Okay, and models explain as async and await. Let's write code that waits for things without stopping everything else in your app. It's like telling your friend, go get snacks from the kitchen. I'll wait here on the couch until you come back. So it came up with an analogy that model thinks 12 years old will understand. Yeah, and then it goes on to explain async and await words. Is it the best answer? I don't know. But developing prompts, it's a very iterative process. Even to get to this one, I tweaked it multiple times and yeah, and tried to get it to return some sensible prompts. Yeah, chain of thought pattern. Yeah, as we saw how model work, it constantly generates predictions, and it can't kind of stop and think. When it's generated something, it's already generated. It can be changed. So sometimes it's useful to describe model steps you would like the model to take to arrive at the output we need. So in this example, I asked the same question. I use a pattern, but I changed explain to product manager, and I asked model to follow certain chain of thoughts. So I asked it to provide technical details using understandable to the audience analogy, benefits relevant for the audience, and additional things to consider. Yeah, so it basically explains it, but now it comes with an analogy about ordering a food in a restaurant, classical analogy, and it provides a list of benefits. Asynchronous code reads similar to synchronous blocking code, making it easier to write and reason about. Avoid callback pyramid with cleaner code. That's one I can definitely agree. And tasks can run in parallel without blocking main thread. Yeah, it can be done different ways, but good point. Additional consideration, error handling is a bit different with async await. Understanding thread safety is still important, and performance difference to know between async and sync. Yeah, this kind of stretch. But yeah, so if you want to experiment, and it works especially good if we need to solve some complex task, because large language models are not so good in splitting difficult tasks in a smaller, simpler task. So, but when we provide the steps for model, it's much easier for model to provide useful outputs. Yeah, and at the end, I would like to discuss some tools we can use to pair program with AI. First one is Copilot. Copilot is a tool from Microsoft and GitHub, and it basically provides a way to have a code completion based on LLM, and these LLMs are specifically trained on a large amount of code from GitHub. It can complete code, it can understand context of your app, it can read your directories and repositories to provide meaningful completion. The only thing for now is the only way to use Copilot is to use Visual Studio Code with a Swift extension. So we need to jump back and forth to edit code in Visual Studio Code and then to Xcode to run and build our app. So Copilot can complete code or provide a set of additional suggestions how can we complete. It's very useful for generating cases like this when we want to provide custom stringlet or convertible conformance, or generating test data, or generating Swift previews, SwiftUI previews. Also, Copilot has a chat, and chat can understand context. For example, in this example, I ask chat to explain dynamic member lookup just by selecting it. So it can explain it on its own or in context and can help it to understand what it's doing in this particular code base. Yeah, additional good use cases for generative AI, discovering Swift packages. Sometimes when we have a task, complex task, we can think maybe this task already implemented with some package, and it's very fast way to find package to just ask ChatGPT, for example. And large language model can not only suggest, but compare different packages and select one based on your use case. Converting from legacy code, converting from Objective-C is really easy with LLMs. And yeah, Xcode has a built-in converter from Objective-C, but with help of generating AI, we can convert and also conform output to Swift guidelines to not make it like direct conversion, but convert it with a Swift specificity in mind. Writing unit test and generating test data. If we structure our code well, if it has a lot of protocols, we can easily generate unit tests and test data for SwiftUI previews. Yeah, all tasks when it's like a monotonous, not creative tasks can be done quite easily. And multi-platform development. It's not cross-platform, but multi-platform. For example, we have the same application on Android. If we have data layer with data classes, it's very easy to convert them to Swift structs and conform them to codable. Yeah, it's no need to do it manually. We can just convert them using generative AI. And brainstorming and evaluating ideas. If we have idea, we can use persona pattern. We can ask what would skeptical computer scientist would think about this idea or architecture. We can tap into different layers of knowledge. We can ask what product manager can think or client from particular domain. Answers may be not so good as discussing it with real customers, but sometimes it's beneficial to have idea if we have complex domain, what stakeholders can think, just to start iterating. And at the end, future, with news like this, Apple bought Darwin AI. It's a Canadian startup, which is researching possibilities to use small and fast LLMs that can run on device. Apple invested a lot in generative AI, and they're aiming to include generative AI features in iOS 18. And Apple is getting serious about AI, and when Apple is getting serious about something, it would be great. Maybe not the first version, but 2.0 for sure. And also Apple creates their own innovative models. So it's kind of clear that next Xcode will have something similar to Copilot. So yeah, I think in the future, for Apple, generative AI will be a huge part of the ecosystem, and I'm really looking forward to next WWDC to what will be announced. Hopefully, it will be part of CoreML in some way. Yeah, that's it. Thank you.